lecture. So I welcome you all once again. So myself Prasanna Kumar, manager in the GATE Academy and also faculty for mechanical engineering subjects of SOM, engineering mechanics and machine design. So I hope everyone is familiar with the GATE paper pattern. So you have 65 questions, you have 30 1-mark questions and 35 2-mark questions, and total marks will be 100 marks, and you'll be having multiple choice questions and you'll be having numerical answer type questions. So the questions are of two types basically, whatever may be the subject, numerical answer type and this multiple choice questions here. So in multiple choice questions you'll be having negative marking. So though it is already known to many number of people, most of the people, I am emphasizing once again to make you know that as there is negative marking for multiple choice questions, whenever you are not 100% sure about any answer, you should never ever go and attempt to give the answer for that. Unless and until you are 100% sure that that is a correct answer, you should never ever attempt that or never ever attempt that question. The reason is you are having negative marking. So if the question goes wrong, you will be losing. That means instead of getting instead of getting 0 marks, you are going to get negative marking. So negative marking means you are going to deduct from the marks you already got from the correct questions. So which is very, very bad thing. That means your effort which you have given already for the correct questions is going to get wasted. So suppose you have attended 4 questions correctly, and let's assume 2 of the questions are 2 marks, so 4 marks, and another 2 questions are 1 mark, so 4 plus 2, 6 marks. So from this 6 mark, you are going to deduct the marks. Okay, so you should be very serious about this thing. So in this classroom or in this live lectures also, I advise you all to maintain the same. Don't do the guessing game. Don't think. I'm not telling you people to I'm not discouraging you people to think smartly, but I'm discouraging you people to do the guessing game. So you should never ever guess. If you think a question is in such a way that it can be solved in a smart way by looking at the options, then you should definitely going ahead with that type of approach, because you should think smartly. In fact, thinking smartly will be giving rise to huge amount of difference between a topper and a normal conventional hardworking person. Imagine you are smartly solving a question and solving within some 30 seconds, let's assume, and a person who didn't thought in a smart way and who is going with the conventional way of solving it completely, starting with every step and everything, let's assume he's solving within 1 minute. Okay, so the person who has solved smartly has saved 30 seconds, right? So let's assume on an average for every question he's saving 30 seconds. If he had solved 10 questions in that way, he will be saving 5 minutes. 5 minutes will be sufficient enough to solve some very difficult question, very lengthy, tough question. Understand? So the smart guy will be solving 1 question extra as compared to the slow and conventionally or traditionally solving guy. So this is the way in which you can save time. So in fact, whatever the couple of seconds you are saving by thinking smartly will help you a lot. In fact, in this classroom session also, in this live session or classroom session also, I'm gonna help you in thinking smartly. Okay, so wherever possible, I advise you all to think smartly to get the answer for the question. But again, coming to the main point, never ever do the guessing game. If you think that out of 4 options, 2 options are right, that means out of those 2 options, 1 of them is right, and you're not completely sure, I advise you not to attempt that. Okay, so because there is 50% probability that your answer going to be wrong. Okay, but there is no something like 100% probability that your answer is right. Unless and until 100% probability is there, that answer is right, you should never ever attempt that question which is having negative marking. If you take numerical answer type questions, you will not be having any negative marking. So you can, if you have a doubt or if you are not sure about the complete answer, you can give that answer there, because if it is wrong, you'll be getting 0 marks. 0 is higher than a negative marking. 0 is higher than -1/3 or -2/3. So though it is many students are already familiar with me, and a few people are almost near towards the GATE examination, I'm again telling this thing because still now also people don't realize this and do that mistake. That's the reason why I would like to convey this thing. Never ever do the guessing game. Understood? So we are studying the SOM subject because we cannot go ahead with the assumption that the body is a rigid body. The reason is the first subject which we study before SOM is actually engineering mechanics. So we study basic physics in our 11th and 12th class, majorly the 11th class concepts, and from there we built up the concepts to study engineering mechanics. And from engineering mechanics we understand or we study the subject of SOM. In engineering mechanics we go with the default assumption that the body is a rigid body. And you guys know what is a rigid body. The member will never ever experience any sort of deformation, no matter whatever is the magnitude of force or stress is applied on it. So, but in real scenario, every material, whatever you take a stone, you take a rock, you take any hard material, whether you take diamond also, it will undergo some deformation due to the application of load or stress. So that is completely possible. So there is no perfect rigid body on earth. But to understand concepts at a basic level, to understand equilibrium concept, to understand many basic concepts, we have gone with the assumption that the body is a rigid body. Okay. Now, we cannot go with the same assumption forever because in real scenario we have deformable solids. So we should drop that assumption and increase the level of understanding of the concept towards deformable solids. So that's the reason why we are dropping the assumption of rigid bodies and we are going to study the mechanics of materials considering the deformations. So that new subject is given the name as strength of materials. Understand? So this subject, strength of materials, is having various names. Okay. So it's given the name as strength of materials, mechanics of deformable solids, mechanics of materials. So two things you have to keep in mind here. So here we are going to study about only solids. Second thing is we are going to study about the deformations of the bodies, or we are dropping the assumption that the body is a rigid body. So we are always going to deal with the deformable solid. So it is a study of deformable solids basically. Understand? So every solid will be undergoing deformation and this is a deformable solid. Okay? Kindly keep in mind. So the reference books which I suggest to you people is The Strength of Materials by B.C. Punamya. Understand? Clear? So you can copy the name of the book. Okay. So before going to the weightage of this subject in past few years for mechanical and civil people, I would like to say one very important thing which you should be keeping in mind. I have given you the reference book name, that is B.C. Punamya for Strength of Materials subject. This doesn't mean that you should go today to online Amazon or Flipkart and you should buy that book. That doesn't mean by that. Okay. It's always good to have a reference book. Okay. And in my subject of SOM, or in this subject of SOM, the problem is you will never ever get the complete GATE syllabus from a single textbook. Okay. So you'll be getting some part from one textbook, some part from other authors' textbook, some part from other authors' textbook, and so on. Sometimes you'll get couple of concepts concepts very well explained from authors of other subject textbooks. This also happens. That's the reason why the faculties, whatever I prepared, SOM subject is from couple of textbooks. It's not from single textbook. So from all the textbooks which can help you to the majority of the level and questions, quality and all. Okay, so I found out that book was better as compared to other books. Okay, that's the reason why I given you that textbook name. So how you should be preparing for GATE examination? So when you are preparing for the GATE examination, first and foremost thing is you should attend the lecture, attempt or listen the lecture very, very properly. And you should make the notes. I'll be giving you time and I'll be giving you definitions, etc. You should make your notes in a very proper way. So your notes is the reference. Using your notes, whatever you think you'd like to study from any textbook, you can study from that in that particular sequence. If you are wasting time on the concept which is not taught in classroom, that means which is not there in the syllabus, then you are actually wasting your time. Okay, understood? So you should not waste a single minute or single second of your time on unnecessary concepts which are not there in your syllabus. Already in the classroom, we anticipate many concepts from where questions can be asked, or though it is not strictly in the syllabus, question can be asked. We anticipate such type of concepts and we put such type of concepts already to give a clear idea of the whole subject already in the classroom. So you should not be wasting any of your time on the concepts which are not at all there in your text notebook. That's my first of all primary advice here. Okay, so after completion of every lecture or every chapter. So what you should be doing is basically you are supposed to complete remaining leftover previous gate questions. So in most of the cases, I try to complete all the previous gate questions. So sometimes we miss out, or sometimes I leave some simple questions, simple silly questions, which are very easy, which are formula based, etc. So that we can save time in the classroom, or we can save time in our lecture here. Okay. So after doing that, immediately go with your chapter test. So your steps of preparation for SOM is solve remaining previous gate question. It's a very minor step. It will not take much time. So in every chapter, ideally speaking, you'll be having some 10 to 20 questions, at maximum 30 questions in a chapter of SOM subject. So we'll be already doing some 22 to 25 questions. We'll be left over with 5 to 6 or maximum some, in the worst case, 7 questions. So those 7 will be very easy questions and you can easily solve them. Understand? Now, there is the first step here, so it will not take much time. Understand? After every chapter, this is what you should do for after every chapter. That means once I complete the first chapter, you should immediately go with that one. So once it is over, you immediately go with chapter test. You should immediately give the chapter test. Understand? So many people neglect and do test series a little later, or when they are approaching towards the gate examination, which is absolutely wrong. So test series is the backbone of your preparation. Test series is backbone of your preparation, I'm telling you. Understand? So if you don't solve test series right from start, then you are always going to stay behind the competition, no matter whatever is the effort you are keeping. So the correct way of preparation is very important. So do the chapter test. Understand? So if you use your login credentials, you can access this chapter test. Then once your these two steps are over for every chapter, whole subject is over, you immediately go with subject test. Understand? So these 3 steps are mandatory. These 3 steps are mandatory after every chapter. In fact, for every subject also. So if you are not doing these 3 steps for every subject, then your preparation is not at all in the correct way. So after doing these 2 steps, if you think still time is there, okay, so you should be going along with the faculty. So if you find out still more amount of time, immediately go with exercise books. So this exercise book, it is different for every subject, and on a whole stream, you're going to have around 4,000 questions. So which is the rarest ever you see. That means no other institute in the country is giving you those number of questions for practicing. Understand? Clear? So if you are using our test series and exercise book, your preparation is completely done. Along with the lectures. Okay? So exercise book you should do. In this, every chapter is having 3 levels of questions. So you just complete level 1 and level 2. Okay? So this is the way in which you should do the preparation. But these 3 steps are mandatory. These 3 steps are mandatory. Understand? If you are unable to find time to do this step, it's okay. It's okay. Leave it for revision. At the time of revision, when you're going to study the textbook, study the subject for the second time, you can do this step. Understand? Clear? So you better go with these 3 steps of SOM subject for mechanical people from the past 8 years. We can understand the importance here. So the weightage is very high. Clear? So you can see that the weightage in the recent 3 years is around 12 to 14 marks. So 12 to 14 marks is one of the highest. Understand? Clear? That shows the importance of this subject here. Another biggest importance of the subject is how well you understand this subject will directly relate to how well you understand the subject of machine design for mechanical people, and for civil people, how well you understand the subject of structural analysis will be directly depending upon this subject. So if you are scoring well in SOM means, if you are very well understanding in SOM means, you will be scoring very well in machine design if you are a mechanical student, and same way in structural analysis if you are a civil student. So you can understand that this subject directly affects the way, understanding and marks of other 2 subjects as well, each subject as well. Okay, 1 subject for every stream as well. Understood? So it is very important. For mechanical people, machine design is around 4 to 5 marks. So you can expect like 18 marks are directly being affected by this subject. Same way for civil people as well. So you can understand the importance of this subject. Clear? So for civil people, relatively you have lesser weightage. So you can see that in 2018 and 17 we got around 8 marks, which is appreciable or a little bit decent weightage, but in 2019 we got very less marks, that is 4 marks. So like this little bit randomness is there, but if you are very clear about SOM, then there's a very less probability that you'll be losing marks in that one, because SOM subject is very easy to understand, and all you require is the better level of understanding. So if you are keeping your effort understanding very well in the classroom, automatically once you start solving numericals, you don't feel that amount of difficulty. Of course, in a couple of chapters, variety of numericals are there. There you face little bit amount of difficulty, but they are manageable. In SOM subject, they never ever unnecessarily give some very, very difficult and notorious question. So they always give you a question which at basic level. So though the question looks different or it looks very, very difficult, once you solve it, the steps used will be the normal steps only or basic steps itself. We're going to see the questions. You'll understand automatically from that one. Understood? Okay. So kindly take this very seriously about the weightage of the subject and make sure to do the preparation the way in which I have advised here. So this is the sequence of the chapters which we're going to discuss. So earlier in the month of April, I have gone with a different sequence, and this time I would like to do the SFD BMD part, or basically the bending concept little bit from second chapter itself. Okay, that's the only difference here. Now you guys can go ahead with copying of the syllabus here. So total there are 6 chapters. Sorry, total there are 10 chapters. So first of all, these are the 6 chapters. Kindly copy the slide of first 6 chapters here. Once the copying is over, kindly let me know. You can save time in taking screenshots as well. We can save good amount of time. So what we can do is, we can use that saved time in solving numericals. We can invest more time. Because whenever you see a question, approach is very important. So how you are thinking after reading the question, that stage is very, very important. So whether you get the correct answer or right answer, your actual learning is there at that stage. So strictly speaking, everybody requires good amount of time at that stage or after reading the question. So we can save good amount of time. Clear? So I advise you all, I'm not telling it to be mandatory, I advise you all to take or have the habit of taking screenshots so that you can save time. Clear? So we'll start with first chapter today. So first chapter will take around 12 hours. So today we'll be completing to some extent, and remaining will be completing on the second class. So before going ahead with our first chapter, so we should understand a few assumptions which we take regarding the subject of SOM. So just like we took assumption that the body is a rigid body in engineering mechanics, so here also we go with some assumptions. We drop these assumptions and go to the higher level in the higher subjects, like especially machine design if you are a mechanical student. So here we take ideal situation. Okay, so the ideal situation is depicted by these properties. So first thing is, we expect our material to be homogeneous. Understood? So homogeneous material means, so first assumption is, so homogeneous material means, so many people have confusion regarding this. The correct definition for homogeneous material means same composition throughout the volume. Same composition throughout the volume here. So whatever, for example, you take some beaker and you pour some water, and in the water you add sugar. Okay, so you add sugar and mix it. So let's assume you have added 5% sugar in terms of volume and 95% remaining is water. So you take any drop of water. So you take here, you take here, you take here. So this sugar syrup, if you take it after dissolving of water, everywhere you'll have 5% sugar and you'll be having 95% water everywhere. So if this is the case, we say it is homogeneous mixture or homogeneous material. For example, if you have a scenario where you have added very huge amount of sugar, so which has led to have some undissolved sugar at the bottom. So this is undissolved sugar. Okay. So here if you take a small drop, so let's assume it is having 5% sugar and 95% water. But if you take a drop from here, so you have observed that some 10% water is there and 90% sugar is there. If you take a little drop from bottom where sugar is deposited, undissolved sugar, so you see that this composition is different with this composition. So there is no same composition throughout the volume. So this is non-homogeneous. So this is homogeneous. So we will not be dealing with these type of materials. So here I have explained you the property of homogeneous using a liquid. Okay. So but actually we will be applying this property to solids here. For example, you take cast iron. So cast iron will be having some composition like this, that is 4% carbon and remaining 96% iron. So whenever we take a cast iron, so the best cast iron is the cast iron which is having same composition throughout the volume. So we assume in a default way that everywhere at every point its carbon percentage is 4% and its iron percentage is 96%. If that is deviated, everywhere it is not same, means it's a non-homogeneous material. So we'll not be dealing with non-homogeneous materials. We'll always deal with only homogeneous material. That is the basic assumption in this first. That is the basic first assumption out of all these assumptions we're going to study now. Clear? Understood? Kindly copy this. So second one is isotropic material. First of all, I'll explain you what is an isotropic material and later I will give you the statement. I hope everybody is already familiar with the definition for isotropic material, that properties are same in every direction. Okay. So first of all, let me explain with the example and later I will put the statement. Let's take a rectangular bar like this. Assume it to be a cube. Okay. So because every area will be same here. Every area will be same and every dimension will be same. Understand? Now this is x direction and this is y direction and this is z direction. So I am going with the case that or loading that load is applied in x direction. So along x direction length is L. So this area is equal to A. So we can say that elongation is nothing but simply PL by area into Young's modulus. Understand? Clear? Now I'm taking the same thing. But the only difference is load is applied in y direction. Okay, so every direction there is same length. So I'm taking same length and same area here. So here we will get elongation to be PL by area into Young's modulus. Okay, so here I'm concerned about Young's modulus thing. That's why reason why I took same force, same length, same area in both the directions. Okay. Ideally speaking, strictly speaking, you should be keeping suffix as E suffix x and E suffix y. Okay. So based upon the value of Young's modulus, elongation will be produced. Young's modulus is one of the metal property. So metal properties are like this: Young's modulus, rigidity modulus, bulk modulus, Poisson's ratio, thermal conductivity, density, okay, and viscosity if it is a liquid. All these are metal properties. So metal properties means like, if you metal properties means something like you say if I give you a material, whatever the place you are standing on earth, you will have same values. I mean, you take aluminium will have some density, right? So whether you mine out aluminium and find out aluminium from India, some mine of India and find out density, or if you find out aluminium by mining out in USA, so both aluminium will have same density. Understand? So then only like that density is called as metal property. That's the reason why density is called as metal property. Clear? Otherwise, otherwise that's not a metal property at all. Clear? So same thing here also. Young's modulus is an example of a metal property. Clear? So it is like this. So strictly speaking, Ex, Ey or Young's modulus values you should be using here. So we say the metal to be isotropic. We say the metal to be isotropic if Ex value is equal to Ey value is equal to Ez value. You say the metal to be isotropic if Ex is equal to Ey is equal to Ez. If inequality is there, that means those values are not same, then we say the metal is anisotropic. So in this unit of SOM, we take or we directly in a default way assume the metal to be isotropic in nature only. Understood? Clear whether it is said or not. Understood? Okay. And many people have one misconception. The people think that every homogeneous material is an isotropic material. Okay. So if composition is, they think that isotropic material should be homogeneous. So many huge misconceptions are there. Here I am letting you know here. The strict definition for homogeneous is same composition throughout the volume. The strict definition for isotropic is same properties in every direction. Same properties in every direction. Understand? So these are the two definitions here, and these two are independent. Why I am telling this thing is, we have materials which are homogeneous, which are isotropic. We have metals which are non-homogeneous, still isotropic. We have metals which are homogeneous, non-isotropic, and in that way here. So both are satisfied by some materials. Both are not satisfied. One satisfied, not other one not satisfied. This satisfied, not this satisfied. All these combinations are there, strictly speaking, on Earth. Okay, whether they may be a naturally occurring materials or man-made materials. So there is no strict line that every isotropic metal should be homogeneous or every homogeneous metal to be isotropic in nature. I am letting you know now itself. Kindly be clear about that. So in this way, I am going to clear off many misconceptions. Okay, so kindly listen properly whatever I am saying. Understood? So if these equations are satisfied, so then only we say isotropic. Okay, so if Ex not equal to Ey not equal to Ez, so we call it as anisotropic. Understood? So kindly copy this. And the last assumption which we take is, we always neglect the body weight unless and until it is asked in the question. It is just for our simplicity. It's just for our understanding here. Okay, so we neglect the body weight, because once you understand the concept by neglecting body weight, it becomes very easy for you later directly to consider the body weight as well. Understood? You can solve the same concept, you can solve the same question using the same concept, considering the body weight as well. Okay, you'll get a different answer. That's it. Okay, so at this level, we neglect the body weight. That's all. So these three are the assumptions which we follow strictly to solve any question of this subject. So before again going with the first chapter, we have to understand about some more or one more concept here, that is principle of superposition. So generally, we know everyone what exactly is principle of superposition, at least by understanding level, not at the statement level. But many people don't know its restrictions, or when it is valid, when it is not valid. So we always assume in a default way that it is always valid, but it is not like that. Okay, so that's the reason why I'm explaining it here. And in fact, there is one gate question which is strictly based upon this definition of and validity of principle of superposition only in civil engineering paper. So you can go through the gate question bank to find out the question. Okay, but it is completely straightforwardly based upon the definition of principle of superposition only. Okay, fine. Let me explain the definition of principle of superposition. Let's take a beam. So it is supported like this. So let's assume there are two loads. So there is P1, there is P2. The whole length is equal to L. So you have this is at L1 and this is at L2. You would like to get the value of deflection. So here, for this loading condition, you would like to get the value of deflection at L by 2. So what is the value of deflection at L by 2? So this you would like to get it. Understand? So here, if you are able to do the calculation and get deflection at that location, only due to P1. So due to P1, you are able to get the deflection. So that's a point. Let's assume the deflection produced is equal to delta 1. Understand? And let's take the other one as well. So only due to P2, let's assume at that location, deflection is delta 2. Okay, so only due to P1 deflection is delta 1, only due to P2 deflection is delta 2. Okay, so let's assume you are able to get delta 1 and delta 2 and you don't know delta. Principle of superposition says that delta value is equal to delta 1 plus delta 2. Okay, so taken along with sign. Understand? So this is the principle of superposition. That means effect of multiple loads is equal to algebraic sum of effects of individual loads. Delta 1 is effect of P1, delta 2 is effect of P2. So effect of these multiple loads, which is nothing but delta, is nothing but algebraic sum of effects of individual loads. Understood? So I'm putting the statement here, you guys can copy. So this is a statement, kindly copy this. After this I will explain the validity, which is the main and most important thing which you should understand at this stage. So let's understand the validity of this principle of superposition. Okay. So basically, in this superposition principle, two conditions are to be satisfied. So first condition is stress should be proportional to strain, and second condition is whatever change of dimensions are produced, elongations, compressions, etc., they should be far less than original dimensions. So this can be written in other way as strain far less than 1. So the strain should be very negligible. I'm not trying to say that strain should be 0, but I would like to say that they should be far less than 1. They should be less. Okay, so these two are the conditions to satisfy the condition of, these two are the conditions that should be satisfied to have validity of the principle of superposition. Okay, now if you take the subject of SOM, we always deal with stresses and strains up to proportionality limit. I hope you are a little bit familiar with the stress strain curve, simple tension stress strain curve. So if you see a stress strain curve, it will be having a proportionality limit. Afterwards, it will be having an elastic limit, and these 2 points will be very near to each other. Okay, in this bit of SOM, we always deal with stresses and strains up to this point only. So we always deal with stresses up to proportionality limit and also strains up to proportionality limit. Only these stresses and strains will be dealing in this bit of SOM. Okay, and till this point, this first condition is satisfied. Okay, and also this point or these strains are inside the elastic region because elastic limit is here. So they are inside the elastic region. So we are dealing with elastic stresses and elastic strains, and in real scenario, elastic strains are very negligible. For example, if you are sitting in your home and if you can see the beam of your ceiling or the roof, for your naked eye, you feel that the beam is completely straight. It is not undergoing any deformation or any deflection, but in real, it is undergoing some amount of deformation. So, or it's actually undergoing some amount of deflection. So, the thing is, you should understand that the elastic deflection that is occurring is far more negligible as compared to the original dimensions. Understand? That's why you couldn't see that. Same way, in most of the applications, the elastic deflections are very much negligible. Understood? Unless you take very good elastic materials like natural rubber, etc., there only you will observe to see the elastic deflections are very high. So in a general sense, we can say that the elastic deflections and elongations are very less. Okay, understood? So as the stresses and strains we are dealing in SOM are satisfying this condition and also this condition because they are very less, being elastic in nature. So we can say this principle of superposition can be used without any confusion throughout this subject of SOM. I hope this is clear to everybody. Understood? So I am writing down the statement here. You guys can copy. So the gate question which was asked in civil engineering paper was completely based upon this. So, or based upon these two conditions. That's all.